So we would proceed with solving further examples like we had solved previously. Continue to solve further examples. Still going to share my screen with you. Okay, so let's solve more examples and see where we'll be able to stop today. Let's look at some more examples. Write a C program which will display the first 15 positive integers on the monitor. Write a C program which will display the first 15 positive integers on the monitor. Okay, so first we need to understand what this question wants us to do and what we can apply, what rule that we can apply to solve this problem. So we want to display the first 15 positive integers on the monitor, the first 15 positive integers. That is what we want our program to do. So how do we solve this problem? We start by, we want to use the for loop and solve this problem. So that positive integer could be x. We define it as integer. It could be an x. So our for loop now is going to take this format. For x equal to 1. Okay, so the initial value for your loop should be 1. Why? Because we are writing a program that will display the first 15 positive integers on the monitor, the first 15. So we start from 1, 2, 3, 4, 5, up to 15. That's what we want to have, an output of numbers from 1 to 15. That's what it means. So starting with 1 and stopping at 15, we can write x in two ways. We can write it to be less than 16, or we can write it to be less than or equal to 15. Okay, it should be less than or equal to 15, but in any case, both of them could work. So we're going to be increasing each number, each iteration now, increasing it for each iteration. And that's what we want to do. Then we print f, just display the numbers. We display the numbers. Display each number on a new line. Yeah, that's very important. And then that's a simple solution to this problem. So let's go further and see how this solution plays out on your output screen. So on your output screen, you should have, let's say this is our output screen here. So what we're trying to do is that we take the first value of x to be 1. If x is 1, is this condition correct? Yes, so we increase it. And the next value is going to be 2. We keep increasing it until we get to 15. And if we try 16, it's going to be false. So our output is going to appear in this format. So this is output. So your output is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10. This is how you're going to have it. 15. We stop at 15 because that's the the maximum that we stated there. So that's how the output of this program is going to look like if you solve it in this way. This is how it's going to look like. You have the output there, and that's how you can simply write the codes that will generate this data output for you. Okay. So that's a simple example. Let's move further and see if we can solve more examples that will make you understand how to use the for loop. Okay, we'll take a look at another example here. Write a C program which will display the positive and positive odd integer smaller than 17 on the monitor. Okay. That's our question. So we go ahead and try to solve this problem. Someone asks a question. Alexis, will the 15 be true or false? So let's go back to that question. If you start counting, let's look at the question again. Yes, if you start counting from 1, okay? If you start counting, sorry. If you start counting from 1 and you say that X should be less than or equal to 15, 15 is inclusive. But if there is no equal to, 15 is not inclusive, then you can change 15 to 16. That's what I said. Is that okay? Okay, but you can equally write it this way. It's the same. 15 is inclusive. Is that okay? Alexis? All right, good. Thank you. So we are now writing a program, a C program that will display the positive odd integers that are smaller than 17. Positive odd integers that are smaller than 17. So this will give you an idea of what you want to achieve. We want to achieve positive odd integers that are smaller than 17. So we are saying numbers that are from 16 downwards, 16 up to 1. Okay, so how do we do this on the monitor? They have to be odd numbers, so don't forget that it has to be odd numbers. They're all odd. They should be odd numbers. Odd integers, I mean. All right. Int main, and then so the number we're going to take from the keyboard is X. And what do we do with that number? For X starting with 1, for X less than, smaller than 17, of course. Okay, then what is the repetitive nature of this number? What do we want to achieve? We want to achieve odd numbers. It has to be able to count all the odd numbers that are between 1 and 17. Okay, so to count those odd numbers, we need to increment it by 2. Okay, in that case. So I'm going to explain to you what that means shortly. So if X plus equal to 2 for each case, of iteration. Printf and show. So we're going to show the value of x, each value on new line, and return. So we're going to discuss what this result can yield. So let's see what this result can be. Okay, so we have x, the first x value, and also we have okay, yeah, we have x, the value of x there. Okay, let's go. So the first value of x is going to be 1. Let's say this is test value. So the first value of s is going to be 1. So how do we test for s? So is s less than 17? Yes, this is less than 17. So we say yes. Okay, the test value there is yes. Okay, is less than 17. So since it's less than 17, what are we going to do? Yeah, Mohammed, you're asking why did we not put scanf? Okay, why did we not put scanf? So you need to look into the question, and then you need to look into the solution that we are doing. In the question says we should write a C program which will display the positive odd integer smaller than 17 on the monitor. It's not asking us to take the value of x from the users. We already have it. We already have a range of numbers that's been given. Okay, so we're only going to print it, and the solution is given here already. So we define x as an integer. So x should be between this, and then you print the values of x that correspond to this for loop. That's what we are doing. We're printing the value that corresponds to the for loop. Okay, so you don't need to use a scan. You're not taking the value from the user in this case. Okay, so that's what we're doing here. So let's move on to the test. We tested this positive. Okay, this is positive. Then we had 1. So what do we do now? X value is 1. So x plus equal to 2. What's that going to give you now? For us to get the new value of x, because that in the first instance, we were incrementing by 1. So now when we increment this by 2, the next value of x is going to be 3. So that's the same thing as saying that your current value of x is 1. So 1 plus 2 is going to be 3. Okay. So the next value of x is 3. Is s less than so let me just use t for true, that I don't confuse you. That's true. Okay. Again, we have 3. X value is now 3. So 3 plus 2 is 5. So is 5 less than 17? That's true. Then 5 plus 2 is 7. Is 7 less than that? True. 7 plus 2 is 9. Is 9 less than that? That's true. So you add 9 to 2, you get 11. Is that true? So when you see the order here, these are all odd numbers. So that's how we get our odd numbers. We start with 1. That's the first odd number. Then the second odd number is 3, 5, 7, 9, 11. Okay, so we had used s plus equal to 2 to generate our odd numbers as the repetitive format. Okay, so we continue doing this until we have 13. 13 is is true. Then 13 plus 2 will give you 15, which is true. If you add 15 plus 2, that is 17. 17 is not less s. This is new value of x is s. It's not less than 17. So that's where we stop. It becomes false. And so the output on our screen should show your output is just going to be 1, 3, 5, 7, 9, 11, 13, 15. That's your output now. Okay. So your output is going to show that way for this very example that we have solved here. Okay. So any questions regarding this? Anyone with a question? Did I answer your question, Mohammed? I don't know who this is. You didn't write your name, so I don't know what name to call you. You're asking why we did not write x divisible by 2 equal to 1. Read the question again, and you need to understand what the question is saying. The question asks us to write a C program that would display the positive odd integers that are smaller than 17 on the monitor. We are displaying positive odd integers smaller than 17. So what are those integers that are within 1 and 17? So how do we find those integers that are odd? That's what we're trying to do. Okay. That's what we're trying to do in this case. All right. So we don't need to do that. We don't need to specify that. It's already specified in the for loop. Okay, if you look in the for loop here, it's already specified in the for loop here. So the for loop handles that. So you don't need to put x divisible by 2 again. So the for loop already answers that question for you. So that's the advantage of using a for loop. Okay, so with a for loop, we can actually, solve simple problems like this. Okay. So we move further to okay, if we take that same question, and then we add just one thing to it. Let's take this same question. Can I copy this? And then we add just one more comment to it. It take positive odd integer smaller than 17, and their sum on the monitor. So we're now going to do two things. First, we're going to display all the odd numbers, which we have done. Then the second thing we need to add to it is the sum of these odd numbers. So I will go back to copy this so that we don't, take too much time. So I can copy the same statement and modify it. So I need to modify this statement. Okay, so in the previous time we just tried to find only odd numbers, but now we need to find the sum of odd numbers, and that means we need to add something we called we need to add another variable to that. So we're going to add s, and we initialize s to be 0. It's very important. Okay, you need to be able to initialize your s to be 0. The reason you have to do this is your sum need to take a beginning number of a variable so that your answers can be correct. Okay, if you don't initialize it, you're going to have wrong numbers in the end, and that it won't be consistent. So now we have s is equal to 0 as our starting, if the sum is equal to 0. So we have to find the sum for all of the examples that we're going to be doing. And how do we find the summation of all the odd numbers now? So the first thing that we have done is to get the odd number, which we have successfully completed at this point. Okay, so the next thing we want to find is the sum. So the sum is going to be equal to the sum is going to be plus equal to S. Okay, I'll explain that to you. And then at the end also, we need to print, let me separate this, make it maybe clear. Okay, that's our sum. And then we also need to print the sum. So we print the sum here. Print F. We say the sum is, we are taking that value for the sum, each of it on a new line. I mean, sorry, we print the sum on the new line rather. Yes, okay. So we have to do this. So I would put something else here now to show us how this is done. Okay, so the first instance was that we had found the values of our x, the odd numbers, which we did from the previous time. So these are the odd numbers x. I'll make a table here. And odd numbers are x. And then the sum, which is s, we say s plus, plus equal to x. I hope you know that this is the same thing as saying s plus s. Okay, yeah, it's the same thing as saying s is equal to s plus s. Okay, it's the same thing as saying that is equal to s plus s. Okay, so let's see how we're going to find the sum, how the sum is generated. The first number we had, the first odd number was 1. First odd number was 1. So the sum, initial value of sum s, we said is equal to 0. So we're just going to add 0 plus 1 because the new value of x is 1. X value now is 1. Okay, don't forget that. Let me just highlight this. So since s value is 1, we put 1 there, and this will give us 1. So the new value of s, that is sum, is now 1. So we take the next number, which is 3, in. So the value of s would therefore be equal to 1 plus 3. So that's going to give us 4. You understand? So each time you have a new value for sum, it replaces the existing value. Here, the existing value of s was 1, but we use that 1, like from the example where we gave, we use that 1 to calculate the value of 4. I don't know if you get this. So that's what we're going to do. Sorry, this should be s plus s, sum plus s. So that's like sum plus new value of s, sum plus new value of s. So the sum, the next sum is 4 that we got there. So the new number we have for s is 5. So x, sorry. So s, that is sum, is equal to now the existing 4 plus new x. So this will give us a total of 9. Okay, so we continue. This is how it's going to be solved. So with all of the numbers that we have, that is 7, we have 7, we had 7, 9, we had 11, we had 13, and then we had 15. So we quickly solve for all of this and see what the solution looks like. So this is going to be 9 plus 5, sorry, plus 7. 9 plus 7 is 16. So the next s is equal to 16 plus 9, which should give you 16 plus 9 should give you 25. Sorry. And s again here would be equal to 25 plus 11. Okay, this will give us 36, yeah. So s again is equal to 36 plus 13. So 36 plus 13 is going to be 49. Then the last value, here is how we find the total sum, 49 plus 15. So the sum of this is 64. So by the time we finish, S, total S or sum, would give us 64. So that's what we have there. So this program is going to give you this result. And that's the reason we wrote in this S there, because each time the iteration happens, so each time the iteration happens, we get a new value of S. Each time the iteration happens, we get a new value of S for every iteration that happens, and until we find the final value of S, which is 64. Okay, is there any question in this regard? Anyone with a question? Any confusion? I'm sure we understand this. Okay, so we would now move on to, is that a question? Mount, I don't understand your question. Can you reframe the question again, please? Okay, Jeremy, you're asking if we're supposed to show this procedure or just the code. If we ask you for the output, then you can include the output, but that depends on the question that you have. Okay. Yeah. Okay, and the sum is 64. That's what we calculated there. Okay. So if they ask you for the output, then you should go ahead and, of course, you know, do what we have done here. So I try to explain to you here, you know, how we got the total sum using, because the sum has a formula which we imputed in our program here. So we said S plus equal to X. So this is the same as saying S is equal to X plus S. That's S plus X. Okay, that's the same thing that we're trying to do there. Okay. Maybe we can take one more examples and then I'll let you do the other examples by yourself. And the next class, we will look at while loop. Okay, we should take a look at one example more. Or I'll just go ahead and explain something to you. The examples there, they're practically just simple. Rehan, okay. If you do that and it gives you the sum, fine. But I mean, the computer is going to calculate it based on the formula we use. I saw your question. It's going to calculate it based on this formula. So we did this calculation based on the formula, okay? So for you to get accurate answers, you should always use the formula. So when you use the formula that you specify, it should give you. So we are looking for the sum of the odd numbers. Okay, so if you add all the odd numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 and 15, and that gives you 64. It's perfect, okay? It's good. Right. Most important thing is that you must have the correct something there, 64. the correct number. So I'd like to show to us some things we need to be careful about while we are using the for loop, and then I'll let you, look into the other examples and try to solve them by yourself. I wish we had some more time. I should have solved one or two, but we need to move on. Maybe next class, if you can remind me, we can solve one more example before we go into the second part, which is the while loop for next week class. So I will show you these things you need to be careful about when you are using the for loop as we will round up to this class. So I'll write them down for you. Include So if we had defined something like this, just an example, I will say for a equal to 15 and a is less than 2, a plus plus, increasing increasing the value by 1, and then we want to print something, print a statement like say welcome, print something like welcome home. Okay, and you got to do that on each new line. Something simple like this. Okay, what will be the implication of such program? Let's look at the for loop a little bit more and try to see what will happen here. The start is 15. The initialization number is 15. But the condition, the stop condition says A must be greater than 2. So each time A is greater than 2, you increase it by 1. So what is going to happen here is that this loop will continue for an infinite number of time, meaning that this loop will never stop. It will never stop. It will be infinity. So welcome home will continue to display on your screen for eternity. Okay, because there's no stop condition. The stop condition will never be violated. It's never going to be false. Because the more you increase 15, if you increase 15 by 1, you have 16. If you increase 16 by 1, you're going to have 17. If you keep increasing it, you never get a negative answer. So this particular kind of question, you need to be careful so that you can set a stop condition that is appropriate. Okay, a stop condition that must be false. But if there's no false stop condition, then it continues and it never stops. Okay, now let's look at another one again. Just copy this and paste here again. So I would edit this a little bit, and take this out of it. Let's take this out of it. So what's going to happen in this place? So A is 15, initial value. A is always going to be greater than 2, definitely, because 15 is greater than 2. Okay, but thereafter, what's going to happen? So this loop is going to repeat itself, but no number other than 15 is going to be there because we didn't specify what should happen to A. So we're going to have something like 15, 15, 15, 15, keep repeating itself, till, an infinite repetition is going to occur here. Okay. Then another scenario we can also have is when we don't have a loop. If we don't have a loop counter. Okay, let's say we take out this completely. And we also take this out completely. There is no counter, nothing to count. So we just put this like this for this. So what are you telling it? there will be no infinite repetition. I mean, there will, by definition, there will be an infinite repetition, and there won't be a loop counter counting how many times or where it is starting from or at what. It's just counting. Whatever you put there is just counting. It just keeps, you know, it doesn't count. There's no counter rather. Okay, so whatever the program it's there, that's what it just displays for you. There's no number specifying it has to start at 0, it has to start at 1, it has to start at 2. There's no starting point, and there is no stop condition. At the same time, there's no control condition there as well. So this just continues to repeat itself infinitely as well. And then we have one more, then I'll stop for today. Okay. Now this, let's make some changes to these. Maybe we can leave this at 15, and then we can make this to be 10. Okay, 15 and 10. So let's change this, less than 10. Now, this type of iteration would never run. And why it's never going to run is because A, the initial value of A, is not less than 10. So as long as A is greater than 10, this is not going to run. This will only run if A is less than 10, let's say 9, or let's say 8, let's say 7. Okay, but as long as A starts from, it's not less than 10, let's say 11, 12, 13 and upwards, this type of loop or this type of iteration is never going to iterate. Okay, it's never going to iterate. Okay, so yeah, so that's where we would stop for today's class. If there's any question, I would take a question. I have a question here. Mohammed is asking if I have a channel on YouTube. Yes, there's a channel on YouTube, and all the classes we have starting from this week are all loaded on the YouTube channel. So if you miss something, you can always go back and you know, try to get it, take a look at it again. Okay, yeah, so there's a channel on YouTube. Any other question, guys, before we would end today's class? If you have a question, you can please go ahead and ask. From Alexander Gabriel. Tokaskika is the first time to participate. Well, because of connection, I need to know how attendance it works. Okay, we're not taking attendance for now. Okay, so I don't know why you're concerned about attendance, but you should be concerned more about learning. There is no quiz assignment for this course. There will be assignment, and I'll let you know when there is assignment. Your assignment is going to be loaded on the e-learning page. So you will complete your assignment. When it's time for assignment, I will let you know, and I'll put it there for you. Okay, so that's all you need to do for now. When there's assignment, I'll let you know in the class, and then you can follow that up. Any other question? If there's no question, then we can call it a day for today, and I'll see you again next week, Wednesday. To have a lovely